Hey everyone, in this video I'll be explaining four-wheel drive. Now first things first, you may want to review my video on the Ackerman principle. This is how the front tires and the rear tires will move at different speeds because of their different radius. So I've attached an annotation somewhere around here. And also you may want to look up differentials and see how differentials work. That would be helpful. So I've attached a link in the description, and there'll also be a link there for the Ackerman principle if that annotation doesn't work quite correctly. So anyways, four-wheel drive. Now many companies will give you a very different definition of what is four-wheel drive. There's full-time four-wheel drive, there's part-time four-wheel drive, there is all-wheel drive, and then there's automatic all-wheel drive. And so for the purposes of this video, I'm going to have two simple definitions which we're going to go by. So, for part-time four-wheel drive, this means you have a high gear and a low gear setting in your transfer case, so you can change the overall gearing of your vehicle. You'd go to a lower gear for more torque, and you'd stay in a higher gear when you didn't need more torque just for everyday driving and basic off-road situations. Now, also with part-time four-wheel drive, you have the ability to switch between two-wheel drive and four-wheel drive. So you can drive just the back tires, or you can drive the back tires and the front tires. Now, full four-wheel drive, full-time four-wheel drive, you have the low and high gear setting just like you do in the part-time, but the only difference is you cannot switch between two-wheel drive and four-wheel drive. And it does this using a center differential, and I'll explain that a little bit once we get a little more into this. So let's start looking at part-time four-wheel drive. So we've got the front of the car here, you've got your engine connected to a transmission, that sends the output shaft to a transfer case. Now this transfer case sends power to both the front and the rear tires. Now how does it do this? Well, look at it right here. Now this is a very basic drawing, and I'm actually going to do another video which will go into much more detail of how this transfer case works. But for the purposes of this video, I just want the basic understanding to be there. So you've got this shaft coming from the transmission, which is rotating clockwise as I have shown here. Now that disc here that's connected to this output shaft is also connected to the rear drive shaft, so here that goes to the rear tires here. So we're looking at this kind of like looking towards it from this direction. And so you can see that this will go back and drive those rear tires. Now, so here's this one system here, and then here's another disc on the end of a rod here, which is going to your front differential. Now there's a chain hooking this gear here to this gear here. And so as this rotates, it pulls this to rotate as well, and so then you're sending power to the front tires. So each of these will send power to these differentials, and then the differentials will split them between the two front and the two rear tires. Now remember, if you don't understand how a differential works, it splits the power between these two and allows them to rotate at different speeds. So once again, I've attached a video that describes that very well in the description. Now, what's the difference between part and full? How would this diagram change? Well, one basic thing that we would definitely change is we'd have to add a differential in here. Now, you're thinking, why would there have to be another differential if there's one right there? Well, the reason is we're trying to allow this rotating shaft right here to rotate at a different speed than this rotating shaft right here. Now, why would you do that? Okay, so if you've watched my video on the Ackerman principle, you know that when a car goes around a turn, the front tires rotate faster than the rear tires. So if you're on pavement and this is occurring, well, you're going to have some what we call transmission windup, and it's going to cause understeer, and it's going to cause your tires to skid. What happens is your tires in the front want to rotate faster, but they're not allowed to because they'd be locked up in the part-time part four-wheel drive setup. So you add this differential, and that allows this shaft right here, this rotation right here, to be different from this output right here. And so the front wheels can rotate at a different speed than the rear wheels, and this allows you to go around corners and not have this wind up or the understeer or the extra tire wear that you definitely would not want. So the purpose once again of this differential is to allow a different speed at that rod right there than this rod right here, that shaft. Alright, so let's go over some benefits of four-wheel drive. Well, the good, and we're talking here mainly about the off-road side of it where you're in four-wheel drive, and we'll just go back to our example where we had just a straight connected shaft right here. And so it's great for off-road traction. You've got four wheels instead of two trying to move your vehicle forward. So if the back tires are in some mud, well, the front tires aren't, you know, they're on land or something, and then they can pull you up. That's a great thing. The bad side is if you're using part-time four-wheel drive and you go on a paved road, you're going to have this transmission wind up where the front tires want to move faster than they can when you go around a turn. So due to the different speed of the front and rear tires, this causes some problems, and that's the downside of it. Another thing with the full-time four-wheel drive, if you have a differential here, then the tires with less grip are just going to end up spinning, and you're not really going to have the advantage of the 50-50 power split like you have with the part-time four-wheel drive. So you can get out of much more difficult situations with the part-time four-wheel drive engaged than if you were in the full-time four-wheel drive and it had a center open differential. Alright, so that looks like everything for this. Now you probably still have two questions. Now those two questions are, how does this transfer case switch between low and high gear? And also, how does this transfer case switch between just the rear driving and the front driving? The front and rear driving. And those two questions I will answer in my next video on transfer cases. So stay tuned for that, and that'll be next week. Alright, so here we've got our example of four-wheel drive. This is a Jeep Cherokee. And so you've got your engine going to your transmission, and that brings you to this transaxle right here. And as you can see, this will be going to the front. So that shaft goes up to the front differential, which is then sent off to the two front tires. And then also in this transfer case right here, you got this part right here, which leads to the rear differential driving the rear tires.